Okay, this is lesson 8.3 of surface area of 3D objects. So the triangular prisms we're going to start with. So prisms are based and named by what they're sitting on. So they have two faces that are that size. So if it's a triangular prism, there's going to be two triangles. So the triangular prisms are always like this. They have two triangles and three rectangles. And the rectangles are all different sizes. Okay? So we've got a rectangle on the back, okay, and then we've got a rectangle on the bottom, and then we've got the diagonal slanted rectangle coming down, okay? So we are going to find the area of each one of those objects, and then we're going to add them all together. So 2 times base times height divided by 2. What do you notice about the 2's? They cancel, because 2 divided by 2 is 1. So now we've got base and height. Now if we've got a triangle, the base and height are attached to this 90-degree angle. So the base and height are 6 and 8. This is going to be 6 times 8, which is going to give us 48 centimeters squared. Okay, so we did one of our objects. That's our triangles, both of our triangles. Then we're going to now do the rectangles. So we're going to do the bottom green rectangle that it's sitting on. So the bottom green rectangle that it's sitting on is 8 times 4. Well, that's going to give us 32 centimeters squared. Then we look at the yellow rectangle. So this is the green rectangle, this is the yellow rectangle. So the yellow rectangle is going to have 6 by 4, so 6 times 4. To give us 24 centimeters squared. It's a little bit smaller. And then we're going to do our third triangle, rectangle, which is the shaded one. This one right here that's in blue. So the slanted rectangle is going to be a 10 times 4, which is going to be 40 centimeters squared. Now we've got to add up all the 4 numbers. So we are going to add 48 plus 32 plus 24 plus 40. And that's going to give us our complete surface area. So our surface area for this object is 144 centimeters squared. Okay, so as we see, we have decomposed the object. This one did not give us the height, so we had to find the height, which is this number right here, the 9 that I'm circling. So we had to find that one using Pythagorean theorem. Now that we have the numbers, we labeled all of the individual objects. Now we're going to find the area of each object. Okay? Now, the triangle, I've got 2 of them. So it's going to be 2 times base times height divided by 2, but we noticed our 2's will cancel. So now we're just going to get 9 times 12, which is going to give us 108. Okay? So our triangles give us 108 centimeters squared. Now we've got to deal with our 3 rectangles. So rectangle 1, 9 times 5, he's going to give us 45 centimeters squared. Rectangle 3, I'm going to multiply 5 and 15, and I'm going to get 75 centimeters squared. Rectangle number 2, 12 times 5. We're going to multiply those, and we're going to get 60 centimeters squared. And the original 108 from the triangle, centimeters squared. So now we've got to add all 4 numbers. So we're going to add the 108, the 45, 75, and 60. And when you add all of those, you should get 288. Total surface area, 288 centimeters squared. All right, surface area for a cylinder is going to be 2 circles. So our 2 circles are 2 pi r squared. And now the rectangle, this rectangle piece right here, Well, it's length times width, but this is literally, this part here I'm squiggling, that is called the height of a pop can or your cylinder, and then this part here is called your circumference. Well, circumference is pi times diameter, and then we got to multiply it by the height. So pi dh. You will always be given the formulas, but at least we know the parts that it starts with. So we've got our circles here, and we've got our wraparound rectangle right there. Okay? So let's now do an example of that. So the example we have, we've got two of them. Now this one on the left gives us a radius, the one on the right gives us a diameter. We do need to use both numbers. So we're going to say radius is 3, diameter is how big? It's 6. It's going to be 2 times bigger than the radius. Now this guy's got the diameter is 4. We're going to work backwards. How big is this radius then? We've got to cut 4 in half. It will be 2. Good. All right. So we're going to write down our equations. 2 pi r squared plus pi dh. And now we're going to put the numbers where they belong in the equation. So 2 times pi times the radius squared. And in this case, our radius is a 3. And then pi times the diameter, which we found is 6, times the height of our pop can here is 5. All right, now because it's bed mass, we've got a plus sign in there. But everything else is sitting side by side, and when it's sitting side by side squished, it means multiply. So we have to multiply this part and get the answer, multiply this part, get the answer. Then the last thing we do is add them together. So, everybody get your calculators out. Start punching them calculators. Your fingers need to do some walking. This is going to give us 56.5. If the question doesn't tell you how to round the question, always round to 1 decimal place unless they ask you otherwise. Okay, so the rule is to round to 1. The next part will give us 92.4. Pardon me? Wow, that's funny. I totally decomposed those numbers. Okay, 94.2. All right, I have them backwards. Now we're going to add them together. That's going to give us 150.7 centimeters squared. Okay, I want you guys to do B the exact same way. Pause now and play when you're ready. Okay, you've had some time to look at this guy. So now, we put the numbers in the spots they belong. We should get 25.1 plus 75.4 to give us 100.5 centimeters squared. Check your work. Okay, now these are 3D composite objects. 3D composite objects, we're used to doing 2D ones, like a house. So we're used to looking at just 2-dimensional shapes, like a square and a triangle together. Or a circle with a triangle inside. We've done lots of those questions. Well, now we're making them into 3D objects, and now we're going to glue them together. So, whenever we glue a 3D object together, we have what's called an overlap space. And there's going to be what's called a double overlap. And it's because they're glued together on that same spot. Each object has glue on it, which means 2 objects have glue, 2 overlap spaces. So, this is where they talk about our overlap. So now they're saying that when you find the surface area completely, you have to find the surface area of object 1, object 2, and then you find the overlap area and subtract it. Okay? Alright, let's take this step by step. So we're going to do the rectangular prism first. So whenever we have a rectangular prism, that's object 1, that's pretty much a Kleenex box. So basically what we're doing is we're finding the surface area of a Kleenex box. So whenever we've got one of these, we have top, bottom, which is 2 sides times length times width, LW. Then we would have the left and right side, 2 sides times length times width. Then we would have the front and the back, 2 sides times length times width. So length and width go into each of those spots, but they're going to be different for each of the objects. So let's decompose the three rectangles. So top and bottom. So top and bottom, if I were to shade it in red right here, that's our top and bottom. So let's put our dimensions on there. Right here we see a 4, that means this would be a 4, and this part here is a 4. So we know the width is a 4. Now, what is the length of it? Well, the length will be the same as this, which will be a 10. Okay, so we've got our 2 times 10 times 4. And then we multiply it out and get our answer. So 2 times 10 times 4. And that's going to give us 80. Then we do our left and right side. Well, our left and right side is the side that is shaded in gray right now. So that side shaded in gray has a length of 6 and a width again of 4. So we've got 2 times 6 times 4. That's going to give us 48. Then we need to do the front and the back. The front and the back is this striped side that I'm striping right now. So that's the striped side. So the striped side, we have a 6 by width and a 10 long. He is 6 by 10, because this is 6 high. So now we take 6 times 10 times 2. That's going to give us 120. And now what we do is we add all 3 of those numbers up. So we're going to add all 3 of them, and we're going to get our answer for the rectangular prism. 248, well done. 248 centimeters squared. Okay, so now we're going now to the triangular prism. And this triangular prism, remember, has 2 triangles, and the triangle has an 8 and a 6, and it's got 2 of them. So we're going to go, I'm just going to draw my work up here for the triangular prism. So this guy is going to be 2 times base times height divided by 2. And we know our 2's cancel. So we need to put the base and height numbers in there. Well, the base is 8 that it's sitting on. The height is 6 going up and down. So we take 8 times 6, and we're going to get 48 for the triangles. Okay, so we dealt with our triangles. Not yet. We have to do the overlap last. Yeah. We did object 1, now we're doing object 2. Then we do the overlap last. Okay, so now we do rectangle 1. So rectangle 1, we're going to call that the back rectangle that is gray, that I'm shading black. So that's going to be a 8 by 6, which also gives us 48 centimeters squared. Then our next triangle, we're going to do the one it's sitting on. So we're going to color that one yellow. This is our yellow triangle or rectangle. And that's going to give us the numbers 8 and 4. And 8 times 4 is 32 centimeters squared. Our third rectangle is the diagonal one. And I'm going to just outline it in purple here. It's this one right here. Oh, I'll sort of shade it purple, I guess. It's that guy right there. So that our numbers are 10 and 4. So we multiply 10 and 4, and we're going to get 40 centimeters squared. I'm just writing in the overlap spot right now because I draw very big. Okay, so we've got all 4 numbers. We've got our purple one. This guy here is our purple one. Okay, there's our purple at 40. Our yellow is at 32, and the black one is at 48. So now we've got to add all 4 numbers together. So we're going to add 48 and 48 and 32 and 40. And we're going to get our triangular prism. And that's going to give us a total of 144. Okay, that's going to give us 144. Oh, hang on. Yeah, the back one is 6 by 4, that's why. This should be a 4, not an 8. So it should be 24. That's why. The one here should be 24, not 48. My bad. I apologize, folks. That's how you get 144. Okay? Now we got to find out the piece where it's attached, okay? So the piece where it's attached and glued together, that's called your overlap. So your overlap piece, that's that black piece that I've got shaded in black right there. That's that piece right there we got to cut out. So our overlap piece is this shaded black one, and it has numbers of 6 and 4. And 6 times 4 is 24. That's our overlap. Okay, so this is the overlap part. So now our total surface area is object 1, 248, plus object 2, 144, subtract the double overlap. Now remember, the overlap, this is only times 1. We got to times it by 2. It's a double overlap. So that's going to be subtracting 48. Okay, that's our double overlap right there. When we add it all up and subtract our double overlap, we should get how big? (344 centimeters squared). Check your work. Make sure you got it written down properly in your equations. Now, number 2, we like this question. We like this question on purpose because they've done all the hard work for us. They found the surface area of object 1, and that is 720. They found the surface area of object 2, 300. All they didn't find was the overlap to subtract it. So they've given us the dimensions of the overlap, but they've shaded it for us. It's this rectangle right there. So we need to do the very last step, which is to find total surface area. And that's going to equal object 1 plus object 2 minus the overlap. Okay? So object 1 is 720. Object 2 is 300. And now we've got to figure out that double overlap. Because it's always a double overlap. So the rectangle right here outlined in red, we need to find length times width. Well, that's 12 times 6. And that's going to give us 72. But we've got 2 of them. It's a double overlap. So we have to times that number by 2. And that's going to give us 144. So our double overlap is 144 that we have to subtract. And that's the only thing we have to do to this question, is find out the part to subtract, and then add it together and subtract the overlap. So how big is the total surface area then? 876, you betcha. So 876 centimeters squared. That is our total surface area. Okay. And again, it's object 1 plus object 2, subtract your double overlap. Okay. Number 3, we need to find, again, 2 different objects. So it's going to be object 1 plus object 2, subtract the double overlap. That's what it always is. So let's find object 1, this triangular prism. So we've got our triangle piece, and then we've got 3 rectangles. So let's put the dimensions on. We've got 4 and 3 for our triangles. If I do the blue one, okay, if this is my blue shaded one, the numbers on the blue shaded one are 4 and 3. And then, if I look at my red striped one, the red striped one is the diagonal line, and that one's going to give us 5 and 3. Then we look at the guy that it's sitting on. I'm going to shade this guy in green. So, this guy here, it's sitting on that little piece there. And that little piece is actually a square. So it's not very big. So, that is a 3 by 3 square. So now we need to find the area of all those objects. But remember, With triangles, it's 2 times base times height divided by 2, but the 2's will cancel. So we're only doing base times height for the triangles. So, let's just move it up a little bit. So now we're going to take, for the triangles, we're going to have 12 centimeters squared. Rectangle 1, we're going to have 3 times 4, which is another 12 centimeters squared. Rectangle 2, 3 times 5, 15 centimeters squared. And then the square. 3 times 3 is 9 centimeters squared. And then we add them all up. So that is our triangular prism, and that's going to give us a total of 48 centimeters squared. Now, which one of those rectangles is it sitting on that it's glued to? The other one. The square one, the 3 by 3. So this 3 by 3 is going to be our double overlap at the end. Okay? So our double overlap is going to be 2 times 3 times 3, which is going to be 18 centimeters squared. So our double overlap is the part we have to subtract. So we've got the double overlap, we've got the top figure, now we need to do the bottom base figure. So the bottom base figure is a cube. So if it's a cube, all 6 sides are the same. So we're going to times it by 6, and then length times width. And this is for the cube. That's the bottom cube. So 6 sides times length times width. And length and width in this case are 3 and 3. So we're going to get 9 times 6, which is 54 centimeters squared. So now the rule is we need total surface area. So to get total surface area, we're going to take object 1, circled in black, plus object 2, circled in red, subtract the double overlap. So 48 plus 54, subtract 18. Will give us our total surface area. So how big is our total surface area? 84, good. So 84, let's put our units in, centimeters squared. Okay, check your work. Okay, we need to find the surface area of the composite object. Well, we like these ones because they already gave us the surface area. So we have surface area at the top, surface area at the bottom. All we have to do is find out where it's attached and glued on. So that's our double overlap right there, that circle. So we need to do 2 times area of a circle. That's going to be our double overlap. And that's the part we have to subtract from those 2 numbers I have in yellow. So 2 times pi times 3 squared, because it gave us a radius of 3 up here. That's why they gave us that number. So we have 2 pi times 9. That's going to give us 56.5 centimeters squared. So now, total surface area. You're going to add the 2 yellow ones, and we're going to subtract the overlap. So we're going to have 56.5 plus 240 minus 56.5. What did you notice? 2 of the numbers are the same. So 56.5 is the whole area of the top, and it's also the area of the double overlap. That's okay. So it's the part that we're subtracting. So this number up here cancels out our double overlap, so our answer is 240. Okay, so your answer will be 240. Because the double overlap is the same size as the top. So total surface area, 240 centimeters squared. Now we're going to do the bottom. The bottom, they didn't solve it for us. We have to solve it. And there's lots of steps. Well, not too bad, actually. Okay, so gave us the surface area of a cylinder formula. That's the part we're going to do first, is the cylinder. So, our radius is 2, the height is 10. So, surface area of our cylinder is going to be 2 pi times 2 squared for the radius, plus pi times diameter of 4 times height of 10. So that's going to help us find the surface area of our cylinder. Okay, so write the numbers down, put them where they belong. Let's leave it up here for you. This should give us 25.1, and this should give us 125.7. When we add that all together, we should get 150.8 centimeters squared. Now we're going to find the area of the double overlap. We already have it. So everybody look up here, and I'm going to show you, I'm going to outline it here in yellow. This circle right there, that's where they're attached in glue. So the double overlap would be the area of those two circles, which is the area of these two circles right here. So that part in yellow I just highlighted is also the double overlap. Okay? So we're going to write down our double overlap is 25.1 centimeters squared. This is the number we have to subtract at the end. Okay? So we need to figure out this big rectangle box on the bottom. Okay? Now, the way to do that one is to do front, back, left, right, top, bottom. So that's exactly what we're going to do. So, front, back, 2 sides times length times width. Top, bottom, 2 sides times length times width. Front, front, back, top, bottom, left, right. So you have left side and right side. 2 sides times length times width. So now we go to the object, and we actually have to take a look at the object and see which side it's talking about. So, let's pay attention over here, please. So, front and back. That's this piece right here I'm coloring in blue. Called the front and back rectangle. And if we want, we can draw the rectangle. That's this rectangle. It's 15 by 12. So, 15 by 12. Then we have the second rectangle. And the third rectangle. So the second one is the top and bottom. So that one I'm going to do in red here. So the red one, we notice is 12 going one way and 15 the other way. So it's the same size, 15 by 12. Then we need the left and right. And what do you notice about the sides of the left and right? And I'm just going to highlight it in yellow. This left and right side, what do you notice the sizes are? What's the length and width of that yellow one? What's that number there? 12, good. And the one going across is also 12, so it's actually a square. It's not a rectangle at all, it's actually a square. So this one's 12 by 12. Now we multiply and find all three answers, and then we add them up. So we're going to get 360, 360, 288. Now we add it up. That's going to give us 1,008 centimeters squared. But we're not done. We have one final step. We have one final step. So the yellow object is right there. The green object I'll do on top here. That's this one. And then the blue one is the front. Okay. All right. So now our job is to add the two and subtract the double overlap. So object 1, 150.8 plus 1,008 subtract 25.1. And that's going to give us our total surface area. That's going to give you 1133.7 centimeters squared. So that's our total surface area on that one. Okay, this concludes lesson 8.3.